Hello and welcome YouTube, Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always it is an honor and a privilege to be serving you here today, as it is every day here at my virtual classroom. Step inside, we are going to deal with trigonometry. Now I've done videos if you've been following me in the Big Ideas Math Integrated Math 2 textbook, section 9.4 on the tangent ratio, 9.5 on the sine and cosine ratio, a bit of 9.6, we solved right triangles completely. We had to use trig and inverse trig for that. I want to combine all of that into I guess two videos here again. They will be two separate videos for two separate worksheets, but if you see them all as one, I'll be combining them all within one thing. First, we're going to talk about using trigonometry to find missing sides, and then use trigonometry to find missing angles. But what I wanted to do was put sine, cosine, and tangent all together on single worksheets. Now, this particular one is on finding missing sides, so the next one that follows up will be finding missing angles. There will be word problems with these as well. If you want to follow in the description section down below, check out the PDF and follow along with the timestamps for this worksheet. 10 problems on the front of some basic nature, and then 6 word problems. And then the next sheet has some more of those kinds of things where we find missing angles. Get your calculator ready if you want to check this thing out. I'll go relatively quickly here. This is assuming you've already picked up on some of the information that you've learned on section 9.4 and 9.5 from the Big Ideas Math Integrated Math 2 textbook. Without further ado, let's go ahead and check this thing out. Now, everything I do is going to be based off the premise of good old SOHCAHTOA. SOHCAHTOA, whether you treat it as one word, 3 words, what have you, the sine of an angle is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, tangent of an angle is opposite over adjacent. I'm assuming you know what I mean when I say that. If not, go and check out some other videos, brush up on it, go and type in Google SOHCAHTOA, you'll see exactly what I'm talking about. All right, you know what, let's do what I generally do here, which is getting us a little circular bubble to fill these things out with. There we go, perfect. All right, number 1. 1 through 4, we're going to find the value of each trig ratio, reduce all fractions. We're going to find the sine of C. I don't know C's angle, and we're not going to talk about finding those angles yet. We'll save that for the next one. But the sine of C, they want to know the ratio of that. Sine is opposite over hypotenuse. Opposite of C is 40. The hypotenuse of the triangle is 50. So sine of C is 40 over 50, which reduce all fractions reduces to 4/5. That is number 1. And these go relatively quickly. Number 2. Sine of x, we are also going to be doing opposite over hypotenuse. X is down here. We get 15 over 17. That cannot reduce, so we'll leave it as such. And that is that answer. Very quick, very quick. Number 3. Cosine of angle C. Now, this one, it's a rotated right triangle. Hopefully you recognize the hypotenuse is this guy over here, the 29. Now, angle C is right here. Cosine is adjacent. Let's bring this down. Is adjacent over hypotenuse. So when we take the adjacent to angle C, that's going to be the 20. Hypotenuse is 29. So cosine of C is 20 over 29. That also cannot reduce. That'll be your fraction. Number 4, tangent. We're putting it together with sine and cosine. We have all of SOHCAHTOA and we have TOA. C. 25 is the hypotenuse opposite angle B. Now tangent doesn't use hypotenuse. It uses opposite and adjacent. For angle C, we go opposite, 15, adjacent, 20. Tangent of C equals 15 over 20, which reduces to 3/4. Okay, those are the first 4, just writing out ratios and reducing their fractions. Very straightforward. I gotta sneeze. Or not. Maybe it calmed itself. Perfect. All right. Numbers 5 through 10. This is the crux of what we do. Find the missing side, round to the nearest tenth. Now, these ones are already rounded ultimately. These are multiple choice for numbers 5 and 6, just to make sure you got things going the right way. Let's follow SOHCAHTOA again, right? So in terms of SOHCAHTOA, what you want to do is recognize which parts you have or are looking for with respect to your angle. With respect to my angle of 54 degrees, x is opposite, 38's hypotenuse. Opposite hypotenuse, I want to use sine. The sine of 54 degrees equals x over 38. Now I want to solve for x by multiplying both sides by 38, and I guess x equals 38 times the sine of 54 degrees. This is an exact answer. If we want to get the rounded answer, we're going to type this in our calculator. So I'm going to go ahead and go to my calculator. And remember the warning for these things for trig stuff, if you've heard, make sure you're in degrees. Whenever I pop this thing up, I think it defaults to, oh, this isn't even, button presses aren't button pressing. Give me 1 second, let me fix it. Okay, let's do that again. Button presses. Make sure your mode you are in, not radians, but degrees. Whenever I open up this calculator thing, it resets its emulator state and it always goes back to radians. So I have to make sure to keep doing that as well. Anyway, we're going to be using degrees. We're going to be doing 38 times the sine of 54. Oh, this thing, did it crash again? There we go. 38 times the sine of 54 degrees. And we're going to get 30.74. So 30.7. That's the number we're looking for in here. Let's see which one's going to be that. 30.7, that's going to be D right there. X is about 30.7. Now, I've mentioned this kind of stuff before. Does the answer make sense? As long as it's less than 38, it's going to make enough sense for me to qualify it. I could be wrong in other instances. I won't be. But, I mean, when you're answering these, just make sure you know it shouldn't be more than 38. All right. Number 6. I have the 17-degree angle. Opposite of that is 28. Adjacent is x. Opposite and adjacent, TOA, uses tangent. Let's take the tangent of 17 degrees, and we will be getting opposite 28 over adjacent x. That's our setup. Now, if I multiply both sides by x, times x on both sides right here, this will get it out of the denominator. That's really that first step you want to do. As well as you want to divide everything by tangent of 17. I'm going to write these all in one step. You don't have to do that, but all over tangent of 17. Okay, so these cancel out, the x's cancel out there. Ultimately, the x and tangent of 17 switch places. You'll be left with x equals 28 over the tangent of 17. Now, when it comes to this kind of answer, I'm not going just based off the visual, but the visual is a good representation of what we have. 17 degrees is a very small angle, and opposite the smallest angle is the shortest side. So x should be, as it looks, considerably longer than that. So I'm going to make sure that whatever I get seems to align with that. 28 divided by the tangent of 17. See, if you did times the tangent of 17 or something like that, you get a different answer. Yeah, definitely. 91.58, etc. 91.6 is what we're looking for there. 91.6, and that looks to be this answer, B. It's not degrees, that's a length, and we got it. Oh, that was number 6. I apologize. Normally I move that thing over. All right. Number 7. 53 degrees, I have the hypotenuse, and I have the side opposite the 53 degrees. Kind of like number 5 there, only it's not multiple choice. And I said that out of order, right? I said a hypotenuse and then opposite. Does that mean I do hypotenuse over opposite? No, none of the basic trig functions do hypotenuse over opposite. Sine does opposite over hypotenuse, though. So it doesn't matter what order you say it. It does matter what order you write it, but the opposite and hypotenuse, we use sine. The sine of 53 degrees equals x over 38. So x, multiply both sides by 38. We get 38 times the sine of 53 degrees. Notice how each time I am writing the exact answer before I approximate it. I think that's very helpful for several reasons. Number 1, rounding error. Number 2, typing something in the calculator wrong. You just, things like that. Number 3, you have a precise answer before you have the rounded. And I mean, that's just really an important thing to practice doing. Never skip that step. If you make a mistake, I can't account for that. A teacher can account for that. 38 times the sine of 53 degrees will be 30.3. Here on out, I'm probably not going to be showing the calculator quite as much unless I want to make a point about something. So just kind of, that's why I said use your calculator as well and check it out with it, or just trust that what I get is correct. All right, it's less than 38, so I'm trusting that. And look, I mean, this is really close to this problem. I think it's just a way of saying, are you doing what you're supposed to be doing right? Number 8. X is the hypotenuse. 26 is the adjacent to this 37-degree angle. Let's use cosine for that. Cosine of 37-degree angle is adjacent over hypotenuse, 26 over x. As you saw from this number 6 problem before, the x and tangent of 17 switch places. So here the x and cosine of 37 will switch places. That's not a magic step. We're treating it like one, but mathematically, we multiply both sides by x. We divide both sides by cosine of 37. So let me do this on my own. 26 over cosine of 37. And we are getting 32.5555. It's about 32.6. 32.6 units there. All right, numbers 9 and 10. 2 more before we dive into the word problems, which are more of the same. We just got to draw it and set it up. Number 9 looks like a tangent problem, opposite and adjacent. Remember, the hypotenuse is this guy opposite the right angle. We don't know hypotenuse. We don't care about hypotenuse. We care about the adjacent leg that we got to get given this angle and the opposite. 35 is the opposite. Adjacent is x. Switch places, right? Multiply both sides by x, divide both sides by tangent of 31. And we are getting about, I don't know. I expect it to be more than 35, though. It's one of those things where it's not just the visual. It's one of those things where, 31, sorry, I'm typing this in. 58.2. It's one of those things where 31 is a smaller angle than this, which would have been, what, 59 degrees right there. So opposite a larger angle should be a longer side. And then number 10, again, hypotenuse, which one? Is it this one? Nope. It's this one right here, the 39. That's your hypotenuse. 67 is the known angle measure, and x is adjacent to it. So we are going to use cosine. The cosine is 67 degrees equals x over 39. Multiply both sides by 39, you get x equals 39 times the cosine of that 67 degrees. And calculator, ahoy. Yeah, if this is your first time looking at trig stuff, maybe you're following along going like, okay, I get what you're doing and I'm going to follow the process. Good. But there's more to like, why are we doing this? How does this make sense? What's your calculator actually spitting out when it does it? What does it know? What does it know about sine, cosine, and tangent? What's working? Save that for other videos that I've made. Oh, number 10. Sorry, I didn't actually put the thing over there. But that was number 10. 15.2. Makes sense as an answer. It looks good to me. All right, let's dive into the word problems on the back. Let me get that circle thing ready here. Let's start with this number 1. Now, if I don't know what my PDF has, but I know on some of my PDF things for students, I drew out the first 3 for them. Okay, a boy flying a kite lets out 300 feet of string, which makes an angle of 38 degrees with the ground. Assume that the string is straight. How high above the ground is the kite? So we have a few parameters here. We have ground. We have a boy, but the boy's not doing very much here, just kind of hanging out. He's flying a kite. Apparently the kite's kind of on the ground here because they're not talking about the boy holding it like 5 feet above the ground. But he lets out 300 feet of string. So here's your string. Here's your kite, for example, flying. And it makes an angle of 38 degrees with the ground. That's what we're looking at right there. Now, they're asking how high above the ground is the kite. This is our unknown, if I call it h or x or whatever. Basically, all these word problems, a right triangle can somehow be constructed. That's the whole point of this, using trigonometry to answer the question. This looks just like a right triangle that we'd have with opposite, unknown, hypotenuse, known. We're going to be using sine for this situation. So the sine of 38 degrees equals h over 300. So h is 300 times the sine of 38 degrees. And that's about, let's go to the nearest tenth. 184.69, so 184.7. Now, this answer, because it's a word problem, needs units. This is in feet. That's how high above the ground the kite is here. This is a very, by the way, all these answers that we do and such, this trig, it's a very common practice to be able to use these things to estimate heights of certain things. Pretty cool. Now, what you notice on this one problem, you're going to see it on other ones as well, is like I said, you have a right triangle. You have something that's horizontal, you have something that's vertical to be perpendicular with it, and something of some sort of length. Whether we're trying to find it out or whether we know it is a way different story. Number 2, a ladder leaning against a wall makes an angle of 74 degrees with the ground. So let's say I have ground like this, and here's a wall like this, and I have a ladder that looks like that. Let's kind of draw ladder looking. All right, so I got my somewhat ladder thing going there. Cool. All right, there's my ladder. It makes an angle of 74 degrees with the ground. So here's my 74. Let's try that again. Here's my 74 that I have right there. And this is a right angle, by the way. That's a right angle. Remember, this is a... Oh, I messed something up. I don't know what happened. This is a wall with ground. So they meet at a right angle there. And there's a 74. If the foot of the ladder is 6.5 feet away from the wall, how high on the wall is the ladder? So we know that this guy right here is 6.5 feet. That's this distance right there. And we want to know how high on the wall is the ladder. They're not asking how long the ladder is. They're asking how high it is right there. What is that? H, basically. You can use X, doesn't matter, but that's my setup. So right triangle, we know the 74-degree angle. We're trying to find opposite. We know the adjacent. This will be tangent. The tangent of 74 degrees equals opposite over adjacent. We'll multiply both sides by 6.5. And once again, write the exact answer first before you go to calculator mode. 6.5 times the tangent of 74 gives me 22.66, so about 22.7 feet. Now that is the height of the ladder on the wall. We never did answer how long the ladder is. Could have asked. It didn't. But you probably would have used cosine for that scenario. All right, number 3. A straight road to the top of a hill is 2,500 feet long and makes an angle of 12 degrees with the horizontal. Find the height of the hill. So this is something where, let's say we're talking about, it says a straight road, but let's say we're talking about like a nice green hill and it kind of has a downhill. It's a little too slopey. And, you have something like a car driving on it as well. So I got a car, beep, beep. Terrible looking car. Vroom, 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 driving uphill. Now this hill measured, let's do it kind of like that, just to kind of get the line going. This hill measured is 2,500 feet. Now it says it makes an angle of 12 degrees with the horizontal. What's the horizontal? It's an idea of if this car could drive through the hill or through a tunnel in the hill or something like that. That's the horizontal that the car is like driving on the ground. This part here is 12 degrees. Clearly not drawn to scale, but there's the 12 degree bit. So let's find the height of the hill. So they're asking, how tall up does this hill go? Basically from ground level, if you were underneath a point on the top of the hill, how far down are you? Or how far up is something above you? That's a right angle because there's horizontal and heights perpendicular with that horizontal. How high up is that? That's what they're asking. Terrible looking car, by the way. This is a sine problem. Sine of 12 degrees equals h over 2,500. So height is 2,500 times sine of 12. So those are the first 3 drawing sets. Let's go ahead and calculate what that is, and then we'll move on to the next 3. 2,500 times sine of 12. And I'm getting 519.77, so about 519.8 feet. Now, I was going to say that seems like a lot, but 2,500 feet of road is like a half mile. So, to be 500 feet up higher. Actually, that is pretty tall. 12 degrees as an incline. I don't even know if that's like, I don't know if we see that anywhere. Maybe we do. I got to maybe Google that and see. But that's very sharp. That's like driving up San Francisco streets kind of thing. That's sharp. Doesn't seem sharp, but, we don't drive up 45-degree angle roads either. All right, number 4. An airplane climbs at an angle of 11 degrees with the ground. Probably more realistic for an airplane. Find the ground distance it has traveled when it has attained an altitude of 400 feet. So an airplane, here's the ground. Okay. Here's the airplane's climb, 11 degrees, like that. And there's my airplane doing airplane things. Flying up. 11 degrees with the ground is what its ascent is. Find the ground distance it has traveled when it attained an altitude of 400 feet. Now, altitude is saying if you look straight down from where you are as a plane, this is how tall you are up. That's the 400. That's the known. So let's find the ground distance it's traveled, not the air distance. It's not how long did it travel here. It's from a point on the ground here to a point on the ground here. How far did it go? I'm not going to call it h anymore, at least for ground. Let's call that one x. So opposite, adjacent sounds like a tangent problem. The difference here, of course, is this time x will be in the denominator as the adjacent. Tangent of 11 degrees equals opposite, 400 over adjacent x. We've done a lot of switching places here before. X will be 400 over the tangent of 11. There, that's a degree symbol. And I have no such guess. 400 feet. Oh, this is going to be long ways. 3,000 feet. I don't know. Tangent of 11. 2,057.8 feet. At some point, that extra decimal is pretty negligible, right? It's not really going to mean very much to us for, is it 2057 or 2058? That kind of thing. All right. Number 5. A wire attached to the top of a pole reaches a stake in the ground 20 feet from the foot of the pole and makes an angle of 58 degrees with the ground. Find the length of the wire. A wire attached to the top of a pole. So let's do a pole. I'm trying to kind of make a design here. Let's do a rectangle. Or with let's do one of those pole things like that. All right, there's a pole. And there's ground, of course. We have ground. See, these drawings, man, they need to be super elegant they really need to work out. No, you just need to make sense of the problem and make your own drawing to make your right triangle. But the pole, see, they don't tell you the pole makes a right angle. But it does. It does. Now, there's a stake in the ground. Like, not like stake, but like... And there's a wire that's attached to the top of the pole like this and attached to the stake in the ground. It makes an angle of 58 degrees with the ground. Now, all these problems have been angles of elevation. At some point, I think we got to talk angles of depression. I believe they showed up in the textbook stuff, but that's where angles go downward instead of upward. But 58 degrees with the ground. It reaches a stake in the ground 20 feet from the foot of the pole. So here's the foot of the pole. Here's the stake in the ground. Here's your 20 feet on the bottom. They said find the length of the wire, too, by the way. So this is 20 feet. They didn't say find the height of the pole. They said find the length of the wire, this part, this x. Here's my angle. Here's the hypotenuse. Here's the adjacent. Adjacent over hypotenuse is for cosine. So the cosine of 58 degrees equals 20 over x. This is another place switching scenario. X is 20 over cosine of 58 degrees, which is about 27 feet. I don't know. 20 over cosine of 58. Oh, I didn't do over. I just did 20 times. 20 divided by cosine of 58. 37.7. I wasn't even close. 37.7 feet. Has everything been in feet so far? Hopefully I've been using units. Feet. All right. Last question. And then I'll have another video on trig of angle things, but this is just a worksheet. Henry is flying a kite. The kite string makes an angle of 43 degrees with the ground. If Henry is standing 100 feet from a point on the ground directly below the kite, find the length of the kite string. So Henry flying a kite. So, wait, was Henry? That was a boy. This is Henry. Henry's a man. Henry is flying a kite. The kite string makes an angle of 43 degrees with the ground. So... kite string. Oh, here's Henry. Hello. 43 degrees, not drawn to scale. Kite. If Henry is standing 100 feet from a point on the ground directly below the kite. All right, so here's a point directly below the kite, right? Literally, right angle. And Henry is standing 100 feet from that. So there's the idea there. Find the length of the kite string. And I think that's what I was saying before, is we didn't find the length before. This time we are. It's another cosine problem. It's a lot like this other problem when it comes to setup and solving. So cosine of 43 degrees equals 100 over x. Switch places, x is 100 over cosine of 43. So again, trig, it's a pretty straightforward process to be able to solve these things. It's just setup that's involved, and make sure you have units in your answer. 100 over cosine of 43, and we get, oh, I did 100 times that, like I did last time. I must not be hitting the button. 136.7. 136.7 feet. Now, I forgot to keep telling you whether an answer makes sense to me or not. At least it's more than 100. And that's the thing that raised a red flag for me. I did 100 times cosine of 43, and I got 73.13, which is less than 100, which a hypotenuse should never be in a situation like that. The boy's kite string should be longer than the distance between him and a point directly below the kite. All right, guys, that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. Now, again, this is part 1 of 2 sequential videos on SOHCAHTOA. This was using trig. Next, we're going to use inverse trig as we try and find angle measures. There will be 4 word problems along the way. Hopefully it makes sense. Take care. I will see you in the next one.